This is a swimming pool full of water, and this is a wall in the swimming pool. The wall is made of cement. I'm going to throw a stone in water at this position. The stone hits water, hits the water surface, and circular waves appear. The circular waves or circular wavefronts here, they travel in all directions. They are traveling in all directions. But this part of the wave is traveling towards the wall. It will hit the wall and reflect back. In this video, we are going to study how to draw the reflected wavefronts. But at first, you have to know that this point where the source hits the water surface, this point, called source of reflected waves. So point S, source of incident waves. Source of incident waves. To draw the reflected waves, the first step is to draw a straight line from the source of the wave to the wall. But this line should be perpendicular. Should be perpendicular, not any line. It should be perpendicular to the wall. We measure the length of this line. We observe that it is 6.5 centimeters. Then I have to extend this line inside the wall the same distance. So if this length is 6.5, if this length is 6.5, I need to extend it another 6.5 inside the wall, so that this length equal to that length. The end point of this line, I'm going to denote it with capital letter R. R will be the source of the reflected waves or reflected wavefronts. How to draw the reflected wavefronts? At first, you have to draw one of the directions of the incident wave. Any direction. Let us say that this direction. Then you are going to measure the wavelength along this direction. We know that the wavelength is measured along the direction. We observe that this wavelength, you can measure this one, you can measure that one, you can measure that one, no problem. We observe that this wavelength here now in this video, it is 1.5 centimeter. So what to do now? You choose any point you like. You choose any point you like on this blue line in water. And for myself, I'm going to choose, for example, this point. So the first point, you choose it. Any point you like. The next point is not any point you like. The next point should be away from the first point that you choose. The same wavelength, 1.5, so you should measure 1.5. So this is the second point. Then again, another 1.5. Then again, 1.5. Why 1.5? Because I measured the wavelength and it was 1.5. If this wavelength was, let us say, 0.8 centimeter, then I will measure 0.8 centimeter, then 0.8, then 0.8. Now, what is the last step? The last step is get a compass. I have this compass, metallic leg, and I have pencil leg. The metal leg will be placed at the source of the reflected waves, letter R in this video. And the pencil leg will be placed at the first point here, at the first point. Then I draw in water. I keep the metal leg in position. Then, don't move it, Move the pencil leg to the next point. To the next point. Now, keep the metal leg in position and move the pencil leg to the next point. 3 are enough. 3 are enough. Unless he asks you draw 4 or draw 5. But if he didn't specify 3 are enough. I'm going to try to draw 4. I'm going to try to draw 4 reflected wavefronts. Now move the pencil leg to the last point, but take care. Keep the metal leg in position. Now I draw the reflected wavefronts.